Okay, so our first question on our paper 2 revision. So just a reminder, this is the calculator paper. There'll be calculators there for you in the exam venue. So listen through these questions, make sure you're happy, try them yourselves. First, maybe before you go through these videos, pause if you want to as you're going along, and get yourself ready. Question 1, we're going to look at a distance time graph. The travel graph below shows a journey Gareth made yesterday. Distance from home shown on the y-axis, and then what time it was on the x-axis. So question A, if you can see it on the right hand side, how far away from home was Gareth at 3 o'clock, 1500 hours? Let's get a pen. Okay, so if we look at the first of all, the kind of the scale on the bottom, that's 12 o'clock, that's 2 o'clock. So in the middle there, I could write it on, that would be 1 o'clock. So each sort of square, bigger square, is half an hour, 1 o'clock, half an hour, 2 o'clock, and so on. So how far away was he at 3 o'clock? Well, 3 o'clock is there. All right, so here, we're looking here, and he was 6 kilometers from home. At what time did Gareth arrive back home? Well, he left home, he went away from home, stopped, went further away, stopped, came back towards home, stopped, further away, and then back, and finally got home at this time here. And we've got to again be careful of scales. So if that's 6 o'clock, that's 8 o'clock. In the middle is 7 o'clock. And in the middle between 7 o'clock and 8 o'clock must mean that this time is 7:30. Sometime after 5 p.m, Gareth headed for the supermarket. The supermarket was closed when he got there, so he headed straight back home. At what time did Gareth arrive at the supermarket? So if it was after 5 o'clock, my assumption is this time here is where he headed to the supermarket. He's got there, and then rather than stay in any amount of time so the line would be flat, he's come straight home. So that time there is 6:30, halfway between 6 o'clock and 7 o'clock. And finally, Gareth did not stop for the whole time between 3 and 3:30, which is here. 3 and 3:30 here. What could the travel graph tell you about his journey between these times? All you got to say here is he is not getting further away from home and he's not getting closer to his home, but that doesn't mean that he's kind of stopped still. Right, as long as he is staying the same distance from his house and not going further away, so he could almost like be walking in a circle around his house, but we don't need to get too detailed here. So all we'll put over here, where's my pen, is not getting closer or further away from home. Okay, or further away from home. You can write more than that, right? But that we've got to suggest you doesn't mean he stopped still. It just means he's not getting closer to home or further away from home. Right, next slide. A couple of questions here. There's the left-hand side and the right-hand side. The left-hand side looks to be a recipe, a spaghetti bolognese recipe, which serves 6 people. Okay, there are other ingredients. I just chopped them off when making this question. Chop them off is good when it's a recipe question. I got rid of them from the question. So 1 onion and so on. How many onions would be needed for 42 people? Well, every 6 people needs 1 onion. So 6 people would need 1 onion. If I made for another 6, 12 people, that would be 2 onions, and you get the idea of what I'm doing. 18 people would need 3 onions, ... And we work out then that for every 42 people is 7 6s. Okay, so I'm making this recipe 7 times, so I'm going to need 7 onions. Slightly more difficult. How many tins of chopped tomato for 15 people? Okay, 6 people. If I double it, that would be 12 people. But then I need another 3. So I'm thinking of 15 as 6 and another 6 people and then another 3 people. So if I'm only cooking for 3, I only need half the recipe. So for the 6 people, I need 2 tins. Right, so this is my tins. Here. For the 6 people, I need 2 tins. To make for another 6 people, I need another 2 tins. But to make for 3 people, I only need half that amount, so I only need 1 tin, which is 5 tins. How much mince needed for 20 people? Even harder, okay, 20 people. So to make for 20 people, I'm going to make for 6 people, and then another 6 people, and then another 6 people. But this time, I only need another 2 people to make 20. So I don't want 6, I want 2, which isn't half the recipe, it's a third of the recipe. I've got to divide that recipe by 3 to work out for 2 people. So how much mince is the question? Well, there was 1,200 for the first 6, 1,200 for the next 6, 1,200 for the next 6. But for the 2 people, I need to divide that by 3. Okay, how many 3s go into 12? 4, and then add the 2 zeros on the end. So I only need 400 to make for those 2 people. Add them together. 1,200, 1,200, 1,200, and 400, you get 4,000. What I didn't spot, but I have now, is give your answer in kilograms. 4,000 grams, so 4, oh, that's meant to be a kg, 4 kilograms. Okay, so I've divided that by 1,000. Just be careful. If it was something like 4,100 or 4,200 or whatever, it would be 4.1 kilograms or 4.2 kilograms, etc. Okay, now we have got a calculator. Okay, calculate 56% of naught of 850 pounds. One way to do this, okay, there are a couple of ways, is to take the number, divide by 100, which finds 1%, and because I want 56%, times by 56. So the big step in a percentage of question with a calculator is always to divide the number by 100, and the reason I'm doing it is to find 1%. Okay, so take 850, I'm going to my calculator here. It's a bit slow loading up. Here we go. So a bit boring listening to this, but I'm doing 850 divided by 100 and times 56, and I get the answer 476. Option number 2, okay, is to take the number 850 and change the percent into a decimal, and 56% as a decimal is 0.56, so you can just multiply by the decimal 0.56 and it would give us the same answer. Now, if the question, okay, I'm not actually going to go into this, I don't think, but if the question had said to increase 850 by 56%, not only would I have to have worked out the 56%, which I've done here, but I would have needed to take the original amount and add on the 476 onto it to increase by that percentage. Okay, I'm doing this without a calculator, but you have got a calculator. Okay, so 1,326 pounds. Depends what it asks you, whether it just wants the percentage or whether it wants you to increase by the percentage. Oh, I've crossed this out. Maybe I was silly to do it. Let's take a quick look at it anyway. Anusha tries to calculate 7% of 1,250. She writes the following, and she's kind of used, right, so what she's done, because I've crossed it out, is she's times the number by 0.7. But if she times it by 0.7, she's actually working out 70%. So the mistake is what she should have done is multiplied by 0.07. So what Anusha is doing, she's using my second method here of changing the percent to a decimal and multiplying by it. Okay, hopefully that makes sense. Next slide. Okay, on this slide, change 3.5 kilograms into grams, 1,000 grams in a kilogram. Okay, so we're going to times that by 1,000 for 3,500. You might get a question that asks you to write something as a ratio. You need to make sure the units are the same. So like this part B here, write the quantity of apples, which was 3.5 kilograms, to the quantity of blackberries, which was 475 grams, as a ratio. So I need to write those two numbers in a ratio, but one's kilograms and one's grams, which is the whole point of what we've done here to change it into grams. So 3,500 to 475. If it asks you to simplify or to write it in its simplest form, you've got to divide both, like you would simplify a fraction, divide them both by the same number. Quite difficult to think of a number that goes into these two. You could divide them both by 5 and then look again, okay? But you might spot that these are both in the 25 times table. So I'm going to divide them both by 25 to get 140. And if I divide this one by 25, I get 19. And I can't simplify any more than that, so that's done. Okay, next question. Fruit tarts are made using strawberries and raspberries. 5/8 of the filling is strawberries. 3/8 of the filling is raspberries. A total of 2,440 grams of fruit is used. Calculate the mass of strawberries and the mass of raspberries. So 200,440 grams is the combined fruit. 5/8 of that being strawberries. 3/8 being raspberries. So I've got to work out 5/8 of 2,440. But I've also got to work out 3/8. 2,440, And hopefully my two answers add up to 2,440 if I'm working out 5/8 and 3/8. In fact, this question could have said 5/8 are strawberries and the rest is raspberries. It didn't need to say 3/8. Could have just said the rest. And a lot of questions will do that. We'll give you one fraction and say just the rest is raspberries. Okay. How do I work it out though? I take the number 2,440. I divide by the bottom and times by the top. And the same here. Divide by the bottom and times by the top. Okay, I'm just going to do one of them. Divide by 8 times by 5 equals 1525. And I can either work that one out as I've done it there, or just take that number away from the 2,440, which is what I'm going to do. And it tells me that this one is 915. On to this question. Look, we can read it, and you should read the question, obviously, but what I can see here is a group frequency diagram, a group frequency table, my apologies. It may ask us to draw a group frequency diagram. That would be one option for question here. It may ask us to draw a cumulative frequency diagram, which we'll see how to do later on in this video. Or the other alternative for this paper too is to calculate an estimate for the mean. It is something we've done and done and done, but you are going to have to try and remember, okay? You're looking to do the midpoint of each group times the frequency. The middle number in each group times the frequency. So the first group 0 to 20 as a middle number of 10 times by a frequency of 1. Okay, so middle point there. Okay, the next group has a middle point of 30 but times it by 8 and so on. I'm not actually going to work this out. I'm going to save myself time. Once we've worked out all these answers, okay, once we've done the midpoint of the frequency, we're going to add up the answers and divide by how many people or days or pets or whatever. What I'm talking about here is the total frequency. Okay, so here is the number of days, so the total, how many days were there in total that we were doing this? So in this case, 1, 9, 18, 25, 31. So in this case, you'd be adding up all your answers here and dividing by what I believe to be 31, although you should check that, okay? Not so worried about part B. But other things that we've done here, things that might come up are, what is the modal group? Again, you should be quite happy with that. The group containing the most people. In this case, it happens to be the middle group, and you should just write the full group, 40 up to 60. That's an S, by the way. There. Okay, fabulous. On to the next slide. Okay, a couple of tricky ones here. Starting with an electricity reading. So what we need to do here now, the layouts of these are always very different. What you have to do though is always the same, okay? And you start by taking the previous and the current reading and you take them away from each other. That will tell you how many units you have used. So the current reading is 46,583. Take away the previous reading of 45,468. Means that we have used 1,115 units. Each unit comes at a cost. In this case, the cost is, and I can't quite see it because it says my computer's battery's going. There we go. In this case, the cost is 13.65 pence per unit. So we times by 13.65 pence. Okay, gives us a big number. 15219.75, and it would be quite easy to look at that and go, right, let's move on to the next bit, but that's pence. We have to divide that by 100 to get it into pounds, which will probably mean getting rid of a few decimal places, but again, you've got a calculator. It's 152.1975, but to round it to 2 decimal places, you're better off. The 9 is followed by a 7, so the 19 pence there would round up to 20 pence. Okay, if these two go in. All right, the next thing to do, we have a service charge. That's got to be added on. Let's add on the service charge, £20.56. okay, which comes to, make sure I get this right, £172.76. And finally, VAT at 5%. Again, more percentage stuff. Two options: divide by 100 times by 5, okay, or change it to a decimal, 0.05, and we'll multiply it by 0.05. That's option 2. Okay, I'm going to need definitely need my calculator for that. 172.76 times 0.05 equals £8.64, and add the VAT onto your bill. That was your bill, that's your VAT, and add it on, we get 172, £181.40. Okay. Next question. Appreciate this has turned into a fairly long video, but hopefully worth your while. So foreign exchange, okay? So in a foreign exchange question, you're going to be told what £1 is equal to in another currency. In this case, we're talking about rupees, so it's 99.40 rupees. And it'll tell you how much money you're changing. So we're changing £450 into rupees. So if you're changing pounds into rupees, you times by that number. So 450 times 99.40 to the calculator again. 450 times 99.40 equals, and it's huge because you get a lot of rupees for your money, 44,730 rupees. Part B. Ewan exchanges his money on arrival in India, so he's got his rupees, it's 44,730 rupees. The exchange rate is now £1 equals 99.72 rupees. So he hasn't got that. Okay, he's decided to wait and he's going to get a different amount. However, here's quite a common question. The exchange bureau, so where he's gone, only has 500 rupee notes. It can only give him 500 or 1,000 or 1,500, something in the 500 times table. And he wants to buy as many rupees as he can. How much of the £450 will he spend? So here's what we do. Part 1, we change the money into rupees. 450 times 99.72, which is 44,874 rupees. Then we look at that number and go, but if they can only give us 500 notes, we can't get this 874 bit at the end. How close can we get to this number but going up in 500s? And the closest we can get is 44,500. If they had happened to have 100 notes or 20 notes, we could have got a bit closer, but with only 500 rupee notes, that's as close as we can get. But I'm not going to pay, or Ewan in this case, doesn't want to pay £450 and not get the full amount that he deserves. He's only going to get this amount, so he wants to know how much this should cost him. So he now works backwards. And the opposite of timesing by 99.72 is to divide by 99.72 to work backwards. So let's do it. 44,500 divided by 99.72 equals, and the answer to that is he only spends £446.25, so about £3.75 less than what he was planning to spend because he couldn't quite get what he wanted. So look out for that question, guys. Work out what he wants to get, what the shop is able to give him, and then whatever they can give him, changing it back into pounds, and hopefully your answer is slightly less than what he or she in the question was willing to pay. Okay, on this slide, we're actually going to start with some percentage work, which is we've done a lot of, so I'm not going to spend too much time on this. So increase £250 by 7%. Two options, as we said. You can find the percentage by dividing by 100 and times it by the percent you want. So this would be divide by 100 and times by 43, or divide by 100, even if it's a horrible percent, like 2.6%, that works, okay? The other option is to change the percent into a decimal and multiply it by, so you can times by 7% is 0.07 or 0.43. Bit awkward with this one. 2% would be 0.02, right? But because it's 2.6%, it's not 0.26, which is 26%. It's 0.026. Now, either of those will give you the percentage. Okay, so I'm going to just do the first one, 250, and I'm going to multiply it on my calculator by 0.07, and the answer is 17.5. However, do read the question. It wants me to increase, so I need to add that percentage on to the £250. So in this case, it would be 267.5. Okay, do the same for the other two. I'm not going to do those for you now. A possible question in there about working out the circumference of a circle. Cherry, again, we're probably going back a little bit here. Cherry pie's delicious. So this is something you've got to learn, unfortunately. Okay, might be one formula that would need to be learned for this exam. So to work out the circumference of a circle, it's pi 3.14 in your calculator times the diameter of the circle d. The diameter is all the way across the circle, okay, which might be given, or in this case, what I've told you is that the radius of the circle is 8.7. So the radius is only halfway. So to get the diameter, we'd have to double it, 8.7 plus 8.7, which is 17.4 centimeters. So the circumference of this circle, the distance around the outside, is equal to 3.14 times 17.4. That's not going to be a nice answer. So we to the calculator again, and it's 54.636 centimeters. If I was asked to round it to maybe one decimal place, I'd be chopping it off there. And because the 6 is followed by a 3, it stays as a 6. It doesn't round up to a 7. Okay? Right. Big topic on both papers. Okay? So likely to happen twice. So we're so confident of these coming up in numerous exams that we are testing and testing and testing. Similar shapes where you have two shapes drawn and one is a bigger version of the other. Now, in any one of these questions, a couple of things will happen. It could be that they're two-dimensional shapes. They could be three-dimensional. They could be any shapes, okay, 2D, 3D, but one will be a bigger version of the other, and it will say the word similar. Keep an eye out for that word. These two shapes are similar, okay? And if that happens, you are looking to find a scale factor. You are looking for a measurement on what the bigger shape that you also know on the littler shape. So here, the 3.5 on the bigger shape is x on the littler shape. That's no good to me. The y on the bigger shape is 3.04 on the littler shape. That's no good to me. But this extra length they've given us, this kind of height here, is 4.2 on the bigger shape and 3.36 on the smaller shape. Now those two, because I know them both, will allow me to work out how many times bigger this shape is than this by dividing the big by the little. Okay, 4.2. I'm going to, again, I'd need a calculator. There's a lot of, you're going to have these calculators to the ready, okay? But when I divide them, I get the answer 1.25. Everything on this shape, this bigger shape, is times 1.25, right? Or 1.25 times the size of the smaller shape. All right, what does that mean? Calculate the value of x and y. It's actually easier for me to start with y, and I'll tell you why. Y is on the bigger shape, so y is the same number as this 3.04, but we have to times by the scale factor 1.25, which is why it's important to work that out first. That big divided by little, get how many times bigger is that? Again, not something I'd be wanting to do without the calculator. Times 1.25. And the answer is 3.8 centimeters. However, for x is on the smaller shape. We're actually going to have to work this way. We're going from a bigger number to a smaller number. So we take this number here, 3.5, and instead of times in it to make it bigger, we divide by the scale factor to make it smaller. And the answer is 2.8 centimeters. And then we could put these numbers down here, x and y, as our final answers. Fab. Next slide. Okay, the group frequency table, another group frequency table. We saw one earlier where we did an estimated mean. We're going to have done one in paper 1 where we draw a group frequency diagram or bar chart. But this time it talks about, and we can see it here in this part A here, we're going to draw a cumulative frequency diagram, starting by filling in the cumulative frequency table. Okay, so the first group is 100 to 200. So it's asking me in this table, how many people were less than 100? Well, nobody, because the first group is 100 to 200. How many people are less than 200? This 10 people here, which is where this 10 comes from. How many people are less than 300? Well, actually, this 22 people and this 10 people. So we're adding the 22 on to the 10. Okay, how many are less than 400? This 10, this 22, and these are less than 400. Okay, so add 46 on, you get 78. So if I get this right. And then add 54 onto that, you get 132. Add 18 onto that, you get 150. And add 10 onto that, you get 160 people, which is good news because it actually tells me there are 160. So I've added them up successfully as I'm going along. So part B, draw this. This is your x-axis number. This is your y-axis. So at 100, we're on 0. At 200, we go up to 10. Okay, that's 20. So I'm only going halfway up to 10. At 300, I'm up to 32. Again, it would appear that what we're doing here, every 10 squares is 20. This is going up in twos, okay? So 32 would be come down from 40, 38, 36, 34, 32. I'm not going to be spot on here because my screen's quite small, but you need to try and be more accurate than I am. At 400, we need to go up to 78. That's fairly easy to draw. At 500, we need to go up to 132, about there, I'd say. It's 140, isn't it? Okay, and then at 600 we go up to 150, which is about there, and then we top out at 160. And you can get a ruler and connect line to line much better than I am doing here with a ruler, or cross to cross, I should say. Okay, God, that's not neat at all, but you just to give you the idea. Okay, so they are the big marks. That's the big mark there. Okay, there are 3 numbers we can get from here, right? And we got to know them all. Because we've gone up to 160, if we go halfway to 80, that will tell me the median. But to get it, we have to come across all the way to the line and down. Again, we're going up in tens here, so I would estimate the median there, the median to be about 410. You could be more accurate than me. The other numbers that we might need are, if we half that again to 40, we get the lower quartile. Again, ladies and gentlemen, my apologies about this. This is very rough. I'm going to take mine to be 330. And the other thing we can do is go up halfway between the median and the top, which is to here, and get the upper quartile. All right, so 3 important numbers. And again, whoa, really snaked that one. We're going to go 480 there, okay? If it asks for the interquartile range, it's the upper quartile, which we had as 480. Take away the lower quartile, which we had as 330, and if you use your calculator to take those away from each other, you get 150 as the interquartile range. Okay, those 3 things, lower quartile, median, upper quartile, involve going from the left hand side of the graph across and down, but you also might have questions that involve tell you a weekly wage and ask you to go up and across to find out how many people are below or above. Now, estimate the number of workers with a weekly wage of, and I'm down in past D here, more than £520, not less. Big difference, okay? Well, first of all, I got to find £520, which is here, right? Next job, again, really bad line. I'm not even trying to go straight here, so it's about there, okay? And across to about there, okay? Again, I might be slightly out here. So if I work out what number that is, 122, 4, 6, 8, 130, 132, 134, okay, is what I'm roughly getting at. That number will tell you how many people are below £520, okay? There are 134 people below there, but if the question says how many have a weekly wage more than that, we've got to work out how much it is, what the gap is from this number 134 up to 160, and in this case it would be 26 people. If it asked for that as a fraction, if it did, it doesn't here, but if it said estimate the fraction of workers, then it would be 26 over the total amount of people, which is 160. Okay, that's if it wants it as a fraction. Next slide. And I promise we are coming towards the end because we're already up to half an hour on this video, and I don't want to keep you more than 5-10 more minutes. But that will be a revision pretty much done. Okay, so box and whisker diagrams, very similar to cumulative frequency. We have 5 values here though: a low, a lower quartile, a median, an upper quartile, and a high value. Okay, same here. This is a rainfall question about the rainfall in Trefwen and the rainfall in Norby or Narby, or I don't know. I can't speak very well. Certainly not Welsh towns. Okay, in order to compare the two, I get the best way to compare the two would always be the median. So if the median is higher here, it's likely that Trefwen is, on average, will have more rain if this is rainfall, or if the median is lower like it is here, this is likely on average to have less rain. You can look at the other values, but that's the best one to compare with. But before we even get there, we got some ranges, some medians, and interquartile ranges to work out. Well, the median's easy. Okay, for the first one, it's here, which is 30. And for Norby, it's 28. The range is the high, take away the low. So for this one, 55, take away 5, which is 50. And for this one, 50, take away 1, which is 49. And the interquartile range, just like it was with cumulative frequency, is the upper quartile, take away the lower quartile, 25 for this one. And here, 45, take away 15, 30 for that one. And if you wanted to show you work it out, like for example, what I was doing saying that like 45 take away 15 equals 30, that's what those lines there would be for, if you weren't doing it in your head and wanted to show that. Okay, Iona's going on holiday next April. She's hoping for good weather with hardly any rain. She decides to go to Norby, as I'm calling it. Give a reason to support. It's only 1 mark. Include values. Which is the best way to compare the median? Trefwen's median, 30. Norby's median, 28. The median is a good measure, an average measure. Okay, so we could say, on average, less rain in Norby, 28mm median compared to 30mm. So a lot of lines just for something where you're just comparing a median. So that's the best way to compare 2 or 3 box and whisker diagrams, is to use the median, but they are some of the other values that you might need to work out. And finally, okay, we've talked about the circumference of a circle. That's something you had to do with shape earlier, where we said it was pi times diameter. The other thing I'd definitely be aware of in a numeracy exam is how to work at the area of a trapezium. The area of a rectangle is length times width. The area of a triangle is base times height divided by 2. But the area of a trapezium is given to you. You don't have to learn this, but it's in the front of the book. But it's awkwardly written. It's written in the front of the paper as that. Okay? You need to know how to apply that though. Okay? The brackets first, A plus B. A is the top and B is the bottom or base. Okay? H is the height, but there are 2 spare numbers here. Which of those is the height? Answer that now. Okay, that is the height. It's always the straight height. In fact, that's a red herring here. We don't need that. So what we need to do is half the top plus the bottom times the height. Now, as long as you know where the bracket buttons are in your calculator, you could do this in bit by bit, or you can put it into the calculator in one go, which is what I'm going to do. So I'm going to write a half, okay, times, or in brackets, sorry, open the brackets, 5.6 add 9.8, and then times 2.8. Let me just do that really quickly. Get in there. And the answer is 21.56. Now, because we were working out area and it says give the units for your answer, when we did the circumference earlier, it was the distance, so that would be centimeters. But any area question, centimeters squared. Okay, and to end, questionnaire, criticizing a questionnaire. The kind of things you'll be criticizing are overlapping groups. What do I mean by that? If I said, how old are you? 1 to 10 or 10 to 20. Well, if I was 10, which of those groups would I go in? They overlap. 10 is in both groups. Okay, other things to look out for, a biased location, standing outside McDonald's and asking, do you like McDonald's? Okay, or standing outside a video shop, how many videos do you watch? You know, that kind of thing. Don't stand in a biased location, stand in an unbiased location. Some questions are irrelevant or too personal, like where do you live, right? Unless it's relevant to what the survey we're doing. If the question was, we're looking at income in different areas, then we would need to know where someone lives. But if it's whether they like pizza, asking them where they live doesn't seem so relevant. Other things could be things like time frames. If I said, how many times do you go to the gym? You'd be going to me, what do you mean, right? Or you'd answer me with something like once a day or 3 times a week or whatever. So the question needs to say that. How many times a day do you go to the gym? How many times a week do you go to the gym? So we're looking for that kind of time frame. So those kind of things, okay? There are other things, but they are some just to get us going. Let's now quickly do this one then. So we're trying to work out what sport programs or crime programs people watch, or whether they prefer sport or crime. So the question one, what is your address? What's the point? It's too personal and it's irrelevant. What type of TV program do you prefer? That's absolutely relevant. That is exactly what I need, okay, to know. How many hours do you spend watching television? That might be important to me as well. I'm not saying it's not important, but here we've got groups, so we need to make sure the groups work. So give one reason to explain why question one is not suitable, not needed, and too personal. Okay. Why is question 3 not suitable? How many hours do you spend watching television? Oh, here we go. No time frame. A day, a week, a month. Okay. Or the other thing we could talk about here is overlapping. I've just spotted. Look, less than 1 hour, 1 to 5 hours, more than 5 hours, more than 10 hours. You could argue here that if you were 1 hour exactly, because you liked the program that was an hour long, which group would you go in? So you could definitely say there are some overlapping groups here. Okay. And finally, the survey was carried out by a questioning people leaving a football ground one Saturday afternoon. Criticism, biased, location. Are people leaving a football ground more likely to say they prefer sport programs or crime programs? Right? They should have gone to a town centre or somewhere random to ask this, not outside a sports ground. And that's the end of that. Hopefully you enjoy your revision. And any questions, do let me know on Teams.